Friends, in our previous video, we had a basic idea what enzymes were and how are enzymes basically different from catalyst. Now, let's get into some further details regarding enzymes. So, first is we have something called as enzyme substrate interaction being specific. Enzyme substrate interaction being specific. Meaning that, say you have substrate S1 and substrate S2, and either of this, if this E1 is going to get converted to product 1 in presence of enzyme E1, there should be an interaction between S1 and E1, which is basically a specific interaction. Meaning that E1 enzyme 1 can convert only S1 to P1, whereas it cannot touch S2, okay, converting into P2. So this is not possible, okay, meaning that enzyme requires a specific substrate, okay, so making an enzyme substrate interaction to be specific, okay. So in case of our previous example, we have taken the carbon dioxide plus water giving rise to carbonic acid, which happens only in presence of carbonic anhydrase. So you cannot substitute carbonic anhydrase with some other enzyme. That particular reaction involving that particular substrate requires that particular enzyme. Okay. So why is this? See, in the same example, if this P2 has to be formed from S2, there should be one more enzyme which is E2. Okay. I hope I am clear. So the point which I am trying to convey here is enzyme substrate interaction is specific. A specific substrate requires a specific enzyme to get converted into product. Okay. Now, what makes this enzyme substrate interaction specific? So that's the another part. Say friends, let's assume that this is an enzyme. This is the enzyme. Okay, we call this as A, and okay, let's this be the substrate. Let this be the substrate. Okay. Now, what happens is, see, you have a specific region in the enzyme which you call it as a active site. Okay, which you call it as a active site. Meaning that in this active site, the substrate tend to bind with the enzyme, and this substrate is getting converted to the due product. Okay, due product. You're getting the point? Okay, this is what is called as an active site. Okay, now mostly, I mean, before this, you can take an example of a lock, right? You can take an example of a lock. It has got a hole, aperture, into which we are going to insert the key and open the lock. Now, this lock could be considered as an overall enzyme. That hole is the active site and the key is going to be the substrate. Okay, so let's assume that way. So as a key is going to be specific for a particular lock, a substrate is going to be specific for the particular enzyme. Say in case if I am going to have one more enzyme of this category, one more substrate of this category, I call this as the substrate 1, I call this as a substrate 2. Now, based on the active site conformation, I expect only substrate 1 to bind with the the enzyme. Substrate 2 cannot bind with the enzyme. It needs a separate enzyme whose active site can accommodate S2, substrate 2. Okay. Now, due to this active site conformation, what happens? Okay, this makes the unique active site accommodating the unique substrate, its own substrate, makes the enzyme substrate interaction specific. Okay, you're getting my point? So the point that we get here is that enzyme substrate interaction is specific, and since this interaction is specific, we have lots and lots of biochemical reaction happening in our system as a part of metabolism, and every step requires its own enzyme. Okay. In case of any one enzyme being deficient, that particular step will be halted. There is nothing like a universal enzyme that can catalyze all of the biochemical reaction. Like there is no universal key for the entire work available in this universe. Okay, right. So this point is clear. Second, how does the enzyme is going to interact with the substrate? Is going to be the next thing. Friends, you have an equation. I'll make it here. You have an equation enzyme plus substrate, okay, which gives rise to ES. Okay, this is a transient meaning temporary. Okay, this is a transient enzyme substrate complex. Then you get enzyme plus product. So this is the basic. Okay, this is the basic. What is that? The enzyme catalyzed reaction. Okay. Now what happens is, okay, when this substrate binds to the active site, first thing, when the substrate binds to the active site, the enzyme tries to change its conformation meaning the structure to an extent that it is going to accommodate the substrate more tightly. Okay, then what happens is, okay, the substrate is going to, you know, break the bond, and a new bond should be formed with respect to the product, and all those things is going to happen, okay, in the transient ES complex. I hope I'm clear. Okay, see, enzyme is going to accommodate substrate. Once that accommodation happens, there's going to be a slight change in the conformation of the enzyme. The conformation is going to accommodate the substrate more closely. Then what happens? This ES complex is formed where the substrate is actually getting converted to product. So here it could be EP. And friends, the substrate is getting converted to product, but enzyme retains as it is. Say for example, if we are going to use 10 unit of enzyme, we do get the same 10 of enzyme, making the enzyme as inert. Enzyme actually doesn't get involved in the reaction, but enzyme just catalyzes the reaction, doesn't get actually involved in the reaction. Okay, so what happens is, okay, this is a transient complex. So ES, in which the substrate is getting gradually converted to product, then you have E plus P. So this is how, okay, an enzyme mediated reactions basically happen. Okay, this is a very superficial discussion. So when you go to the further studies with respect to this biochemistry, you will have more and more insights how this things actually happens. Okay, so this is the case. Second is enzymes. How does it works? How does it? I have told in the previous video that in most cases enzyme presence is mandatory for the reaction to happen. So enzymes not just increases the speed of the reaction, but its presence is mandatory, meaning that it makes the reaction to happen. So how exactly it does? Friends, there is a bit of chemistry, so I'll try to explain to an extent here. In the layman term, the substrate needs some energy barrier for it to get converted to product, right? And that energy is what is called as an activation energy. Okay, what energy it is called as? Activation energy. So it requires some energy. It needs some energy, right? So when it gets that energy, say for example, if that energy is going to be say 5E. Okay, so when substrate gets that energy, okay, then it gets converted to product. So this is going to be substrate side, product side, this is going to be 5E. Okay, now usually substrate finds difficult to get this past this activation energy. So what happens? The enzymes, what it does, it is going to lower the activation energy. Say for example, it's going to be 5E. In presence of enzyme, like the activation energy is considerably lowered, say E. Now the substrate finds itself pretty much comfortable in getting this activation energy since it is lowered. So reaction do happen, and also the speed of the reaction is increased. Let's have a very practical example. I am standing here. There is a hill, okay, with a considerable height. Now, for me to reach the other side of the hill, I need to cross the entire hill and then reach the other side. Now, for me to reach the initial case, say assume that it's going to take some 10 hours. Now, for me to reach it in 2 hours, what I should do is, if the size of the hill is going to be reduced, then the time taken for me to reach the other side of the hill is going to be faster. This is something similar to that, right? So the activation energy is the energy required by the substrate for it to get converted to product, and enzyme do lower the activation energy, thereby the substrate is getting converted to product in less time. Okay, so these are all the basic aspects of the enzyme. So to summarize, the enzyme substrate interaction is going to be specific. Okay, that is due to the conformation of the active site which can accommodate only a particular substrate. Okay, and second thing is enzyme is going to be inert here. Okay, enzyme is going to be inert, meaning that enzyme doesn't get involved in the reaction. Okay, they just make sure that the reaction happens. Okay. And third thing is, how does the mechanism or how does the enzyme work? You call it a mechanism of action. So it is going to lower the activation energy, right? So these are some basic aspects of the enzyme. So hope you have understood. In next video, we will talk another aspects regarding enzymes. Thanks for watching.